Okay, in reteaching the learning target 2, I did forget to put one thing on the notes that you guys may be using. I've got the formulas. Notice there are 2 formulas for permutations, the n factorial when you're using all the objects, and the NPR when you're using R out of n objects, 5n. The 10 would be 5 would be the R. And the combinations has one formula, and it's the same as the NPR, it's just NCR, and it has a little different formula to it there. And what it does is it adjusts for whether the order matters or not. And that's the thing I forgot to put on your notes. How do we test if order matters? On our previous notes, it was big, bold, and you test by selecting an outcome and then select the same outcome in a different order, and you ask the question, did the order matter? All right, there was also another way I gave you to test if order matters, and I'm going to show that here too. Okay, so let's do number 10. How many study groups of 3 people can be formed out of 10 students? All right, option 1, we'll use well, first of all, can you turn that phrase into something like 3 out of 10? Does it fit here to pick 3 out of 10? If it feels right to say 3 out of 10, you're choosing a group out of a group, it's going to be a permutation or combination. Order matters or not. So I'm going to literally test this by picking 3 of you right now. Then I'm going to pick the same 3 of you in a different order and ask, did order matter? Okay? All right. Houston, Rachel, Alec. There's my 3. Now I'm going to pick the same outcome in a different order. Rachel, Alec, Houston. Did it matter? And the way you answer that is, did I get a different study group? No, then order doesn't matter. It's a C. Here's the other way you can test that, okay? Here's the other way you can test it. Here are 3 blank boxes. I'm still using Houston, Rachel, and Alec. Does it matter which box I put Alec? Does it matter if I write Alec here or if I write him in a different box? Is it going to give me a different study group? Then order doesn't matter. All right, so that's the 2 tests that I can kind of come up with to give you to test that. Does order matter? All right, back to the problem. If we say order doesn't matter, then it is 10, C3. We'll type that in the calculator. I'll use this opportunity to remind you where those buttons are. Go 10, then hit math, over to PRB, down to the NCR formula, then type 3, and it is doing the formula for you and giving you 120. So 120, you can get it that way, or you can use this formula, which would say 10 factorial divided by 10 minus 3, so 7 factorial times 3 factorial. I mean, you can get that number either way. You do need to know the formulas. If you study this without the formulas and you never use them, you will probably miss at least 2 questions on the test. Not the quiz, but the test. It's going to test you to see if you know the formula. You don't have to memorize the formula. It's on your yellow sheet. Okay? All right, you don't have to memorize it. But you have to know how to use it. All right, now I'm going to let you try. I'm going to pause the video and let you try 11 through 15. And then I'm going to come, and 15 is the hard one. 15 is definitely the hard one. You will have one on the quiz tomorrow like it, something like it. And 14 isn't hard, but a lot of people miss 14. So take a little extra care with 14. All right, now I'll pause the video. All right, so again, if you didn't try those, pause the video and try them. But now we're going to go through them pretty fast. Number 11, pick 5 cards. I'll do it in my head, out loud. Ace of hearts, king of hearts, queen of hearts, jack of hearts, 10 of, that's too hard. Let's start over. 2, 3, 4, 5, 6 of hearts. That's easier. 2, 3, 4, 5, 6 of hearts. Those are my cards. Pick the same cards in a different order. 6, 5, 4, 3, 2 of hearts. Did I get a different 5-card hand? No. So order does not matter. 52, C3. Type it in the calculator. You will get 2 million. Oh, thank you. Yep, thank you. 52, C5. Sorry, thank you. You get 2,598,000 960. How many arrangements in the word tigers is possible? Well, there's 6 letters in tigers, right? And Tigers is an arrangement. As soon as I take S from the back of tigers and put it in the front, I get Steiger. Is that a different arrangement of those letters? Then order matters. Are you arranging all 6 letters? No. How many okay, this is a 2-part question. In the first part of the question, it's asking how many ways can you arrange the letters in tigers, okay? So all 6 of them. It would be 6 factorial. But in the second part of the question, it asks you what if you were only arranging 3. So if you didn't catch that, it is a 2-part question. So 6 factorial gives you 720. But when you're arranging only 3 of the letters, order still matters. So it's 6, but you're only picking 3, so 6p3. And you type that in, you get 120. Number 13. How many ways can you award first, second, and third place to a group of 5 contestants? Well, I'll go back to the boxes. We'll erase Alec here. Call them first, second, and third. Well, if this is a box that represents first, second, and third, does it matter what contestant's name I put in a specific box? Then order matters. You could also test that by picking 3 people and pick them in a different order. But anyways, order matters. So 5, P3, 60. Number 14, nothing real tricky about it except the way it's worded, okay? A bride and a groom, and there's 6 attendants are taking pictures. Not there's 6 attendants. There are 8 people taking pictures, not 6, okay? How many, if she takes a photograph of 3 people in a group, how many different groups can she photograph? Well, bride, groom, father. Father, bride, groom. Is that a different group? No. So order does not matter. It's 8C3. Now, if you actually started, if you worded this problem a little bit different to say, I want the bride in between the groom and the father, I want the father on the right, order would become important then. But this is just telling whoever, go to church or go into the whatever, and get me these 3 people, tell them to come out here, we're taking a picture. It doesn't matter. All right, but you have to pay attention to the wording of the problem because you could easily turn that question into an order matters. All right, and the last one. This one is the most difficult, and again, it's on the quiz, something like it, because it involves both learning target 1 and learning target 2. You are choosing a group of men and a group of women. Agree? Those are your 2 events. Event 1, choose the men. Event 2, choose the women. Learning target 1 would say, however many ways you can choose the men and however many ways you can choose the women, you need to multiply those 2 things. Furthermore, the word is and, which we know from probability experience. When it's and, you multiply. All right, if there are 10 men, you're going to pick a committee of 3, then it's 10 something 3 because you're picking 3 out of 10. Is it C? Is it P? It's C. There are 12 women. You're choosing 5. So 12 something 5. And again, it's just a committee that the order doesn't matter. So 10C3 is the number 120. 12C5 is the number 792. So you multiply those and get 95,040. All right, so that's learning target 2. Reteach.